In this section, we will learn to multiply and divide rational expressions. Here are the steps. Step 1. Factor each numerator and denominator. Step 2. Divide out the common factors in the numerator and denominator. Leave the remaining factors in factored form. Step 3. Remember that if we multiply two rational expressions, then a over b times c over d equals to a times c over b times d. In other words, we multiply the numerators and multiply the denominators, given that the denominators are not equal to 0. Here's an example. Let's multiply the following expression. So the first step is factor each numerator and denominator. So let's start by factoring p squared minus 36. This is a difference of squares, so this will factor to p plus 6 times p minus 6. Now let's factor 5 minus 3p. This is pretty much in factored form. The only thing is that 3p needs to be positive. So remember, when you want to make this term a positive, we factor out a GCF of -1. If we divide 5 by -1, that becomes -5. Negative 3p divided by -1 becomes positive 3p. This gives us 3p minus 5. Now let's factor 3p squared plus 13p minus 30. Because the p squared has a coefficient of more than 1, we will need to use the x factor method. When you do so, we will see that our answer turns out to be 3p minus 5 times p plus 6. On the denominator, we have p squared plus 12p plus 36. The coefficient of p squared is 1, so we can just find two numbers that multiply to be 36 and add to be 12, which are p plus 6 times p plus 6. That's step 1. Step 2, divide out common factors in numerator and denominator. It doesn't matter if the common factors are in the same fraction or in different fractions, but anything from the numerator can divide anything on the denominator. For example, this p plus 6 and this p plus 6, it's a common factor, so they divide to be 1. This 3p minus 5, this 3p minus 5, they divide to be 1 since they're common factors. This p plus 6 and p plus 6, even though it's in the same fraction, it's fine. We can divide it to be 1 because one's on the numerator, one's on the denominator. This divides to be 1. So all we're left with is this p minus 6 on the numerator and a -1 on the denominator. So we learned in a previous section that if we divide by a monomial, then this becomes p over -1 minus 6 over -1. P over -1 is negative p. Negative 6 over -1 is positive 6. So our final answer is negative p plus 6. In other words, p divided by -1 is negative p. Negative 6 divided by -1 is positive 6. Recall that a over b divided by c over d equals to a over b times d over c. In other words, when you divide by a fraction, we multiply by its reciprocal. So for example, let's divide the following expression. First, we're going to rewrite this as x squared minus x over x squared minus 1 times the reciprocal of the second fraction, which is x squared plus 3x plus 2 divided by x minus 1. Now let's factor each numerator and each denominator. With x squared minus x, there's a greatest common factor. We always look for a greatest common factor first. The greatest common factor is x. If we factor out an x from each of these terms, x squared divided by x is x divided by x is 1. X squared minus 1, this factors to be x plus 1 times x minus 1. X squared plus 3x plus 2, this factors to be x plus 2 times x plus 1. And finally, we have x minus 1 on the denominator. Now, we can divide anything from the numerator with anything on the denominator, regardless of it's in the same fraction or different fractions. So this x minus 1 divides to be 1. This x plus 1 divides to be 1. And it doesn't look like we have any other common factors on the numerator and denominator. So our final answer here would be x times the quantity x plus 2. We have x from the first fraction, x plus 2 from the second fraction, divided by x minus 1.